Okay, ladies and gentlemen, welcome to follow the talk by Emeritus Professor Ray Sterling, professor from Louisiana Tech University, USA. Besides Louisiana Tech, he has acted as a professor at University of Minnesota and also acted as a consultant at Sterling Consulting since early 70s. His expertise is in, among others, in underground infrastructures, but also trenchless technologies. Mm-hmm. My name is Mikael Rinne, and I'm a professor in rock mechanics here at Aalto University. This event is organized jointly with the Finnish Tunneling Association and Aalto University. Once again, welcome you all to learn more about worldwide development in urban underground planning. The presentation is recorded and stored, so I also welcome those who follow the presentation from distance. The presentation will discuss the current growth in research and implementation for urban underground planning worldwide. After this presentation, there will be coffee served in the second floor, so welcome also for coffee after this talk. So please, Professor Ray Sterling.
Thank you very much for that kind welcome, and hello to everyone. It's a pleasure to be here. As many of you probably know, although my position is still as a professor connected to Louisiana Tech University in the south of the U.S., my wife is from Minnesota. I spent more years in Minnesota than anywhere, and all our children live in Minnesota. So I'm actually living back in Minnesota that has many ties to Scandinavia. There's significant Finnish communities there, Swedish and Norwegian, and so people in Minnesota feel a very strong connection to Scandinavia. But the topic of my talk today is about underground planning and how that has been looked at worldwide, and I will go through in a little over an hour, I think, the presentation, and then I believe we'll have some time for questions and discussion. So in terms of underground space use planning, we can see around the world that the use of underground space is expanding very rapidly now worldwide, both in urban areas and in for national infrastructures in terms of rail and road. In urban areas, we find that the extensive underground space use only occurs late in the development of an urban area. And that's natural, but unfortunately what it means is that in all the time up to then, people typically have been putting underground structures wherever is the easiest for their own project. And so when you come to important projects like metros, even urban roads, other technical and service installations, they have to fit around everything that has gone before. And in fact, some access to what would otherwise be good geologies may have been shut off by important installations that were put in just the wrong place previously. And also to fit around everything that's gone before, costs go up and project uncertainties go up. And it's always been a little odd to me that, we have a whole planning planning discipline, if you like, to plan the surface of the cities, and yet there's been very little thought given in most cities around the world to planning also for the underground beneath the city. Helsinki being a distinct exception to that rule, because it does. Let me just back up a sec. The picture on the right is the uncovering of Wall Street in New York in 1917. So more than 100 years ago, the underground under downtown New York was already a mess. And you see that people have been thinking about this for a long time. There was a French engineer and planner who wrote about this and produced a number of sketches, like the picture on the right, looking at how might you use the public right-of-way in urban areas to improve transportation, provide better connection into the buildings on either side. There was also the city engineer of Philadelphia in the US who wrote a paper that you can download in 1914 that basically said, we already have a mess under our city streets. We're going to get more kinds of infrastructure that we don't even know what they are right now coming in the future. We'd better plan better for the underground. And then the French in the 1930s, extending all the way through to the 1970s, formed a group to look at urban underground space planning. They had a magazine called Le Monde Souterrain, the underground world, and looked at the architecture, the planning, as well as the engineering of the urban underground. Today, the sort of different interest areas are following a rapid growth of interest and urban sprawl in the 1960s. Some well-publicized environmental disasters that occurred in that time period, and energy consumption and energy use also were things that made people look towards the underground because of the more constant temperature environment. Then the 80s and 90s, early 90s, were the sort of decade of finance was the most important, and so interest in the underground kind of lost momentum. Then in the 90s, it picked up again with realization that a lot of the infrastructure that had been built in the 50s and 60s was already getting old, and not enough money was being spent on that to keep it in current condition. And also, there were rising expectations of the quality of life. Most recently, there's a lot of interest in sustainability and resiliency of cities, how we can provide for our future generations, and how our cities can withstand both natural and man-made disasters. So I won't go through this in detail, but you can track the relationship of building things underground to sustainability, and they believe a copy of these slides will be available, and it's a copy of the lecture. You can look at this at your leisure. But some of the main influences are that using the underground allows you to build a compact but livable city. In other words, you can put a lot of the things that don't need to be on the surface underground. You can still have fairly dense development above ground, but still retain open space. And building compactly has a number of advantages in terms of sustainability. The next two are isolation and preservation. You can kind of group those two together, and you can hide things underground. You can separate them in terms of climate, in terms of vibration, in terms of not being able to see the things that you put underground. That also has some benefits in terms of sustainability. If you think in broad terms, what we know about prehistoric civilizations, most of it, the vast majority of it, comes from things that we dig up or we find in deep caves underground, because those artifacts have been preserved in the underground environment. And finally, the last one, life cycle cost. There are some penalties for underground construction in terms of typically initial cost. Also, sometimes the construction and the concrete that goes into underground construction is fairly energy intensive. But the operating costs may be low in terms of energy. You can have savings in other things like insurance, and you have a high longevity. And on the right, there are some of the disadvantages or limitations that go along with those benefits. So for any particular type of facility, you do need to look at the balance sheet, if you like, as to whether it makes sense or not. Starting around 2000, the late 1990s or early 2000s, a researcher, particularly Dr. Pario from Switzerland, started to try and look not just at using the space underground, but saying, the underground provides several types of resources that are important, and being space, materials, which are maybe under urban areas, groundwater, and also the energy potential. And that we need to look at that whole system rather than just look at the use of the space, because using one of those resources may preclude or damage the use in other ways. And so you can find now in the literature quite a few papers and research projects that build on those ideas. And a lot of that comes down to deciding whether uses exclude other uses, or whether they can be two or three different uses can occur together. This is just a chart to look at dividing the uses of the underground into the renewable and non-renewable. And actually, the use of the underground, while it may help in terms of making the overall city more sustainable, most of the uses of the underground are in themselves non-renewable. In other words, once you use it that way, that resource is used up. The only one that appears on the bottom and on the top is geothermal, and because certainly if you use geothermal at a high extraction rate, then you are changing the resource. If you're extracting heat, that area of the ground is getting cooler, and you're able to get less heat out in the future. If it's seasonally balanced, then it can be, essentially fully renewable. The other big issue I mentioned is resiliency, and certainly that's coming to the fore. We are tending to see more heavy rainstorms, more hurricanes, or more stronger hurricanes, that sort of thing, and they leave behind them at least a temporary damage to the systems that we depend on to live. And the picture on the right shows one way of looking at how to measure resiliency. And without going into too much detail, imagine you have a performance of some system. There's an event comes along, the performance drops, and then how quickly that performance can be restored, and essentially the area under the curve, under the original performance, and between that, like here's the original performance, here's a dip in performance, and it comes back again. This green area is a measure of the resilience of the system. And if the dip is greater and takes longer to repair, then that measures in a bigger area and you get less resilience. So, as in the last case of sustainability, if we look at how does the underground relate to that, we can find that most of the external events, then the underground does pretty well. It provides good protection. Flooding is obviously something that with an underground structure you have to take great care with. But not all underground structures are actually you go down into. If you have a hillside or a mountain, you can have an underground structure that still does many of the other good things of the underground, but it's not susceptible to flooding because you actually go on a level or actually go up into it. Even when you have a big system like a metro, you've got a lot of investment, a lot of equipment, large system, and only a few selected points that connect to the surface. So while it is in one sense vulnerable, it's also something where if you protect those entry points, ventilation points, etc., you can have quite a resilient system. And it's the internal events that give more problem to the underground, like an internal explosion or fire or chemical release. There are ways of dealing with it, but you would have to say that is something that needs a lot of care when designing an underground structure. And without going again into detail, a lot of the problems of resiliency today have not so much to do with the physical infrastructure of any one type, but the fact that everything is interrelated. The telecommunications, the electric power, the water supply, the availability of oil and gas, the transportation systems, they're so interconnected that if any one of those goes down in a serious way, it has a ripple effect through the whole system. And with a lot of automatic controls operating between those systems, in fact, we don't fully understand what the potential impacts are in such complex systems. Let me switch now and go through some different areas around the world and tell you what's been going on or what is going on in terms of underground planning, what has gone on. In North America, there are quite a few large underground projects being built, but not so much activity in terms of underground planning. The center I directed for 18 years at University of Minnesota, that closed in 1995, and there is no similar center at the moment anywhere in North America. In fact, there is a remarkably small number of professors, I would say, and research groups that deal with tunneling or underground construction at all. The Colorado School of Mines is an exception, and there are a few other places. There's plenty of soil mechanics, plenty of rock mechanics, but dealing with underground construction, underground space use, tunneling, not so many. There are very big underground space use in terms of reuse of mine space. I'll talk about that. And there have been some large projects recently that have had major cost overruns or major issues, including the Boston Artery, which is done now, and the Alaskan Highway, where the tunneling is finally done, but tunnel is, I don't believe it's open yet. Boston Artery, the total cost of the projects was estimated initially at about 4 or 5 billion, wound up to be 15 or 16 billion. So it was a big public discussion. Obviously, it made traffic around Boston for 10 or 15 years extremely difficult, but now it is open. It's now, I think starting to be considered a big success rather than a big problem. And the real estate values along the strip that is now a sort of urban linear park have shot up to the point where the increase in value along that strip is probably more than the cost of the construction. In the Alaskan Highway, I don't know how many of you may have read, there was a tunneling machine nicknamed Big Bertha, and that got stuck after only a few hundred meters of tunneling and was stuck for 18 months or 2 years, and led everyone who was against the tunnel to say, I told you so. And so anyway, they got it going again, and the tunneling is finished, and I think it's going to be the same, because the tunneling option in both Boston and Seattle, where the Alaskan Highway is, allowed the city to reconnect to its waterfront. There was a time, and you can see it in cities all around the world, where, okay, the ports are maybe less important, a bit run down, you need better transportation, let's run the freeway right between the city and the waterfront, where the land is cheap and things are a bit degraded. And what that did was, just shut the city off from one of its most valuable assets. And tunneling allows you to undo some of that. We talk briefly about the city of Minneapolis is one place that quite early on did an underground planning study. In lot, because our center was at the university, we were pushing the city to do that. And we cooperated with American Planning Association. There is a planning advisory report dating from 81 or 82 that was published. It had a very favorable layer cake geology of glacial till on top, then a very strong limestone, and then a soft, easily excavated sandstone that was drained out by the Mississippi River cutting through. So you could go in this soft material with a hard material to form a flat roof, spans up to about 15 to 16 meters, and in a dry material. And this layer cake geology extended underneath quite a bit of the Twin Cities, had been used for cheese caves, beer storage, mushroom growing, but we were looking at a more extensive use, and did a planning study. Basically found that the area close to the river, this is the Mississippi River, which was most drained out to give you a higher dry area to work in, and with portal access horizontally from the river was the best. And actually we were then able to preserve a portal access that was built when an archives facility was built at the University of Minnesota, somewhat similar to the Stockholm National Library archives. The archives are down in Rock Carron below. There's a library building existing on the surface that it connected to. But the access point was built in such a way that it provided access to the archives, but also to future caverns. Now, I think if you went to the city of Minneapolis and you walked in and got hold of the planning department, you'd be very lucky if you found somebody that even knew that planning study had been done and probably was able to put their hands on it. And part of the reason they didn't go forward is that Minneapolis is a pretty spread out city, and so although it had a very favorable geology, it didn't really have the economic driving forces to, make people use the underground. We had the climate. We had a climate that's at least as cold as Helsinki in the winter time, and it's also very hot in the summer. The other thing that happened was fairly close to this facility was a gas plant operated by the gas utility, and apparently for several decades there had been leaking of hydrocarbons down into the soil, go through the limestone and got into that porous sandstone. So even for the archives facility, they had some problem with vapors coming out of that porous sandstone with volatile organics in them. So that caused people to say, well, we're really not going to extend closer under the downtown area. We've heard about Kansas City. Are any of you familiar with the underground space in Kansas City? Heard about it? Yeah, a few people. There are probably more than 10, perhaps 15 or 20 different facilities in the region. They're mostly along a river bluff, so you can drive into the underground. They are typically maybe 30 to 50 meters below the ground when you get away from the bluff. There's a very nice parting plane in the limestone, and the rock that is good for aggregate for concrete and for road construction is in this layer. You blast very carefully, and in most areas you can have a roof that really doesn't need any rock bolts to be stable. I think there's about 8 meter by 8 meter pillars, and perhaps, I forget the offhand, but a little wider, maybe 12 to 15 meter span across. And this is a model in one of the facilities, and shows those little dots are the pillars. And this is more than a kilometer in each direction. This is the offices of the management company in that facility. And over all these facilities, there are probably more than 5,000 people working underground doing in industrial, warehousing, and the good part of the National Archives for the country is put in these types of facilities. Actually, the local planning department got involved in helping to facilitate that back in the 1970s and 80s. They changed the zoning laws, and just run through, this is the same facility that was in the model, but a slightly earlier image of the underground, where all those little dots are 8-meter by 8-meter pillars. Here's the bluff along this, along the bottom, and in that shaded area there. The expansion is still going on into the rock while they're using the underground. These slightly darker areas were leased facilities, and I think that plan was made sometime in the 1980s, so much more extensively used now. They were able to bring a railway line in so that a train could be unloaded in the underground. And if you notice the pillars here are all irregular, and here they're regular, except they've been modified to allow a rail line to come in up in that area. And around this time, right here in the expansion, they realized that the eventual use of the space was more important and potentially more valuable than just the mining for sale as an aggregate. So here is somewhere where if I back up, you get space like this on the lower left. That's paid for by the mining. And then you just have to run in lights, put something down on the floor, and you've got an industrial space that they rent for about half of the price of industrial space above ground. Move up to Canada, quite a bit of underground in Canada and mining. But some of the things with regard to planning that it's known for is the underground shopping and pedestrian areas in Montreal and also notably in Toronto. These connect the metro station, the rail lines, most of the downtown buildings, university, many different types of facilities, and make the whole of the downtown a kind of indoor environment. Similar, I know you have pretty much the same in Helsinki here. And I think probably you have some of the same issues in Helsinki. It's a tremendous system. It's enabled the downtown to compete with the suburbs in terms of attractiveness as a shopping and commercial destination. But if you look at part of the system, you can see that the underground pedestrian connections are rather convoluted. And the person who worked with this system said, I always choose one of the worst parts of the system to show. So, but, you know, I think there are parts of the system that are much easier to navigate and more obvious, but that is one of the drawbacks of a system where they basically encourage the developers to connect to the system, but they really didn't control where they connected or, try and put it all into a simple and easily understood system. Let's shift to Europe. As you know, many large infrastructure projects. There's been a sort of re-evaluation and an upgrading of safety systems in the past couple of decades. Scandinavia, and in particular Helsinki, has kind of shown the world, if you like, how to do planning for the underground. Although I think it's fair to say that most of the underground planning effort has been related to the use of the rock resource in Helsinki, as opposed to, let's say, connections like Montreal amongst the downtown buildings. The Deep City project, with its concern for thinking about all the resources, the underground, started in Switzerland. There's quite a bit of interest in urban underground space in Russia, but it's hard to identify exactly if that kind of planning is going on or not. France, that has done a lot with the underground over the years, has been trying to sort of revitalize that interest with what they call the D-Day project, the 10D project. And I think that if you look around the world, in a lot of areas, you can find that underground space use becomes a topic of some significant interest that lasts for a while, and then people get so far with it, and they kind of go as far as they can, and then the interest dies away, and another decade or two later, someone says, hey, we should be thinking about the underground, and then it kind of starts again. And certainly that's been the case in Minnesota. So Helsinki on the left, you know, Stockholm is famous for its Blue Line, and is currently doing a lot of underground construction. Oslo also has this very good example where the freeway that cuts in front of the city hall has sparked over the last 2 decades or so huge redevelopment of that whole waterfront area that must just dwarf the costs of building the tunnel. But you know, just before I move on from that, that's appears to be such a good example, but it doesn't appear to be any analysis of the overall impact. We talked earlier about the cost benefit. I think that in many of these cases we need to get some real estate and planning professors and their graduate students to try and go back and track values and the opinion and all those things to try and track and document whether these projects are, even though they cost a lot of money, are valuable in the long run. The Netherlands, I put 1990 on this slide is because I was interacting with the Netherlands at the time, and these were questions that they posed. I didn't write this. They wrote. I took this off a slide that they had. That they're looking at all the things that they were facing in the Netherlands about, lack of land, being the crossroads, one of the ports to Europe as a whole, environmental concerns, and figuring that, on the right-hand side, what are we going to do about it? Are we ready to do that? How are we going to do it? Who's going to do it? Who's going to pay? Do we have a policy? And they shifted around 1990 from having very little underground tunneling and underground works to actually in the universities and in the planning departments shifting to really look at not only underground but also multi-level planning for their spaces. And within about 5 to 10 years, they did the Green Heart Tunnel, which was really sort of on the forefront of tunnel boring. They introduced tunnel boring machines that they hadn't used before, and they had big research departments, for instance, in Delft University. And some of the cities now have underground planning specifically in the charter of the planning. And for instance, in city of Arnhem, the public and private projects now must specifically consider underground space use, the planning. And the city of, I'm not sure how to pronounce it, Zwolle. Okay, Zwolle. They also developed a 3D vision, and you see the separation on the right between the occupation space, the network space, and the what they call a deeper underground space with the groundwater and environment, etc. UK, another country, huge amounts of underground construction, especially in London, but not so much, cross-disciplinary or cross-infrastructure planning for how to use the underground. It does appear they're finally going to build the tunnel for the road near Stonehenge, which has taken a long time to come about. And they do have an interesting activity, the ITA, Committee on Underground Space. They have a younger members group. And one of the things that Ethicus has been doing in connection with one of the planning groups, I can't remember the acronym for it, but anyway, they've been hosting 1 week design charrettes with the young engineers, a couple of senior people. City of Glasgow, for instance, had them come in and look at one area they were looking to redevelop. And those really, have developed some very nice ideas. They're great training for the young engineers and planners and architects, and I think a very successful program. This image is of the redevelopment of Les Halles in Paris. It's for the last 40 or 50 years been a major transportation and intermodal hub. But starting off as a very successful shopping area and attractive destination. As I understand it, they gradually had, they found that they brought in some young people attracting stores. That attracted young people to hang around there. And then a lot of the wealthier shoppers found that they didn't really then like to go there and hang out, so the higher end shops disappeared. And it kind of got into a little bit of a downward spiral. And so this is part of renovation and an effort to kind of revitalize that whole area. And also it's 50 years old, so it's probably time for a renovation. Australia, again, you go back into the early 90s, virtually no tunnels. There was one Sydney Harbour tunnel built in the 80s, I think, and that was the first road tunnel in Australia. You might say, why does Australia need underground space? It's it's the least densely populated continent in the world, probably, but its urban areas are crowded, land values are high, and they have as little surface space as anywhere. And so I was fortunate enough to be involved in a study over about 18-month period with about 90 or 100 Australian multidisciplinary groups, lawyers, finances, geologists, engineers, and we produced a summary report which we called Down Under, which they liked, but this momentum changed. When I left there at the end of the city, head of the city, the Sydney Planning Department had said, yes, we're going to do a master planning for Sydney Underground. And I called and talked to someone about 9 or 12 months later. I said, how's that planning study going? And they said, oh, well, the mayor, they changed mayors, and now there's no interest in doing that anymore. So, you know, things that happen that should be, you know, they're so important that they should be independent of a few key people, but they're not. They require the dedication, if you like, or they're required to be built in so that they happen even with the changes of interest over short periods of time. But Sydney has gone on. They're building many underground projects. It's not stopping underground projects, but as far as I know, there is no overall master plan for that in Sydney or any other city. China must be building more underground space than anywhere else in the world. They apparently, at any one time, they have perhaps 500 tunnel boring machines operating, probably more than that now if someone has different statistics. They build these massive intermodal developments. This one's in Beijing, to connect high-speed rail to airport, to bus, to taxi, to metro. And in this picture here, I forget how large it is, but this whole center open space being built in one of the cities in China is underlain by 2 or 3 levels of underground space for parking, commercial, and other uses. And connected with that, they have also been doing a lot of work on planning, and a lot of that is accessible, but not so much in the English language. And so if you want to access that, you probably have to link up with someone who can read and speak Chinese. But Beijing has got a slightly different approach than Shanghai, but they are both related to sort of dividing up the underground into depths for different types of uses. And as many other areas around the world have found, China's been building a lot of things underground for the past 20 or 30 years, and now the new types of things they want to put underground, new metro, new high-speed rail lines, are having to go down into the very deep 40, 50 meter plus depths in the underground. There was a big national program to encourage multi-utility tunnels, and one of the latest things they're looking at is freight tunnel systems for freight delivery around the major cities, because they're finding that a lot of their traffic congestion in the city now, it's not just rush hour congestion, but it's all day long because people are ordering things on the internet and having it delivered. So, and there's actually a new, very large program under the auspices of the China Geological Society to look at deep underground space use planning. it has a few things that don't seem to really go together, and which is like deep geologic exploration along with urban underground space planning. But apparently that is because there were those two initiatives and somebody in the government decided to put them together. So it's kind of didn't really come from the bottom up, but that linking was done from the top down. Japan has had a long history of underground development. They did in the 80s and 90s a lot of work on underground planning. They also passed a new land ownership law. It took them about 15 years or so to think about it and get it passed. But they were also facing this being forced deeper and deeper underground, starting with the original Ginza line, the metro that was between 15 and 20 meters down, to the newest lines that are down around 50 meters. And their underground land ownership law, which applies underneath three of the major urban areas, basically said that if you're more than 40 meters below for a public purpose, you can do a tunnel without having to go through all of the land ownership agreements with all of the individual property owners. If you already have a foundation here that goes down to depth that would be more than that 40 meters, then the public space would start 10 meters below the foundation. And they've also looked at the different aspects of using the underground even for utilities. Taking a city, a small city like this with overhead power lines, putting those utilities underground, cleaning up the signage, and over a period from 1992 to 10 years later, number of tourists increased from 350,000 to 3 million. So again, you come back, it's often very hard to justify the high cost of underground construction, but there are real, economic benefits if you can just document them well enough to be able to use them in an argument. Current initiatives, the economy over the last 20 years in Japan has kind of damped down a lot of their development work, and there is a group called the Urban Underground Space Center of Japan, and one of the things that they're working probably most on is trying to improve the urban underground spaces. Particularly, they've done a lot of work in and around Tokyo Station on the Marunouchi side or the Yaesu side. Now, the last two examples are Hong Kong and Singapore. And let me just check. Am I okay for time? Yes. Yeah. Okay. So this reads from the bottom up. So in Hong Kong, which, as you all know, has a high population and fairly small land area, they've been looking at using the underground for a long time. One of the things that and I'll explain it more in a later slide, but the very, very densely populated areas of Hong Kong with 100-story buildings they're in the kind of flatter land right around the waterfront. There's quite a bit of Hong Kong which is public park and consists of tall, very steep-sided mountains. And those are both protected and also not very easy to build on. So a lot of the interest in the underground space use in Hong Kong is in some ways similar to Scandinavia, and that's why there's been good links. It's how can we use the good rock conditions they have in the hills to provide facilities that can ease the pressure on space and provide needed facilities. They did an underground oil storage study in 1982. There was what they call the SPUN study in 88 to 89. And then a lot of work on rock cavern uses, including fire safety and a GeoGuide for their design, and on up to later studies. Still these mostly related to caverns, but in the more recent years, not only the cavern development, but if you see a Hong Kong study and it talks about urban underground space, they make a little distinction between the caverns and the urban underground space. The urban underground space is more like the Montreal development, and the cavern space is more like the rock cavern developments here. So they apologize for the poor quality of these images, but here you have Hong Kong Island, and this is the Kowloon area and what they, I think, call the new territories. And these are some of the different underground projects that had been looked at. And over the years, they've been gradually refining this cavern suitability map. And the green is good suitability. The red is poor suitability for caverns. And I think there is a different shade of green, brighter green, which is the good rock that is close to where the land value is the highest and the space is needed the most. And and they also have the major faults and problems delineated on that. The other side of one is the geologic side. The other side of what they've been doing is trying to say, what can we put underground? And that's partly the technical nature of the facility, but it's also the political feasibility to put those things underground. So it's easier to put government facilities underground, but it's also not that easy to put government facilities underground because the head of department or the key people in those departments may not want to be moved underground. And they may not want to be relocated away from key sort of nice areas along the waterfront back into a rock cavern on the other side of the downtown. Maybe better for the city as a whole, but not necessarily better for them or their workforce. But it's clear, for instance, that you can move a sewage treatment plant from expensive land on the waterfront. You can move it into rock cavern, build the whole facility, expand it, and the land value release on the waterfront will much more than pay for the costs of rebuilding it in the rock cavern. Some typical types of projects, there's a lot of transportation-related projects, road tunnels, metro tunnels, rail tunnels, etc. But this is one sort of cavern use, which is a saltwater storage cavern. They use salt water for cooling, and this is on a university campus there. They had planned some surface tanks, and they looked at instead building a rock cavern, saving the surface use on campus, and it turned out to be a much preferable idea. So the Hong Kong government has the use of underground space is formally in the highest level of government documents, and so they do have that kind of authorization, and they have been developing this long-term strategy for cavern development, public engagement, etc., finding out what uses to put underground, the most preferable to do that. And these are some of the more recent studies. Here is the underground space development, which is more about interconnectivity of the buildings downtown. If any of you have been to Hong Kong, there's a lot of people walking about, but over the years, I think they've given preference to easing the traffic. And so actually you're walking along a street that it looks like you can walk right down this street and get to where you want to go, and all of a sudden there's access to a freeway ramp just cuts you off, and okay, where do I go? And so they're trying to solve some of those issues and make it easier to move around Hong Kong as a pedestrian and reduce the pedestrian traffic conflicts. So the high land costs and the land use issues are driving the interest in Hong Kong. But there's still some ongoing work to do to make all that happen. So let's move on to Singapore, and I have a couple of colleagues with me here from Savannah Jurong company in Singapore that are involved in a lot of the infrastructure work there, and obviously very interested in how Singapore can use its underground space. This is an interest that started in Singapore, I would say, in the early 90s, and has kind of gradually picked up steam ever since then. They approach things in a very thorough, methodical fashion, and they either at the end of this year or probably next year, they're going to release their master plan for underground space use in Singapore. So it's been the result of, from the early studies through to now, perhaps 20, 25 years of gradual development. Singapore currently has a population of somewhere close to 6 million. It has somewhere just over 7 million, no, sorry, what is it? 7,000 square kilometers. No, anyway, I forget the exact figure, but if you divide it out, when the population would be just over 7 million, each person in Singapore would have 100 square meters of land, and so 10 meter by 10 meter space. And of that, 20% is reserved because Singapore is a country. It has national defense. They take about 20% of the land. Roads take about another 20% of the land. The housing takes about 20% of the land. and I think that parks and open areas are about 20% of the land. So it's very, very densely populated. It plans to increase its economy, and so how does and it's also trying to improve its quality of life. Over the past 20, 30 years, they've actually increased the amount of open land available in Singapore, and they plan to continue to try and do that. So how can you increase your economy, which probably means more people coming into Singapore, improve the amount of park area, improve the infrastructure, and one of the only ways that you can do that is to put the things that don't need to be on the surface underground. Two buildings shown here. One is the Marina Bay Sands Hotel with these artificial trees in the gardens by the bay. And this is a departmental building on the NTU, the Nanyang Technological University campus in the western part of Singapore. So it's been building a lot of infrastructure underground for the past 20, 30 years, including some multi-utility tunnels, taking freeways that were on the surface, moving them underground and making them larger. Also deep sewer tunnel system, deep cable tunnel system. So a lot of that work has been going on, but they've also been looking at space uses. There's a lot of soft ground and high water table in Singapore, but there is also some hard rock. There's northern center part of Singapore is some hills, and it has underneath a pretty decent granite, the Bukit Timah granite. And in the Bukit Timah granite is the Mandai ammunition storage facility. They moved that underground, and because they can store the ammunition closer together, and they could move it underground, they actually saved more than 1% of the land area of Singapore. So, I mean, it's pretty significant, right? The Jurong oil storage caverns are underneath the seabed and partly underneath Jurong Island. It's part of Singapore. Scandinavian firms very much involved in the design and the construction of that cavern. So like Hong Kong, the impetus to look at underground space was elevated to the highest strategic level by the Singapore government in 2010. These were the recommendations to work on. So creating basement spaces. This is what Hong Kong would have called the underground space development, because there's a lot of pedestrian traffic conflicts in Singapore, and their pedestrian system is not that so well interconnected in the underground. Developing an underground master plan, actually establishing a national geology office. As I understood it, they used to have a national geology office, and then it sort of almost disbanded or for about 20 years or so. There really wasn't a lot of interest in collecting all the geological data until they revitalized that office, and now they have a very good plan and system for mandating the collection of the information and the software and system to to use that. And they've really looked to what Helsinki has done and what the British Geological Survey have done to act as their models, if you like, for why and how to do that. And they've also been a strong investor in the universities and in terms of R&D. One of the things that they did fairly quietly was to basically take the British model of, or a lot of countries' model of land ownership that you own to the center of the earth, and say, well, we're going to clarify that. And in fact, you only own to 30 meters, 30 meters down. And like in Japan, they took the Japan model as well. They have some other caveats on that, but this, you know, to make it easier to do underground developments that might extend under private land. Some of the different projects, this is the deep sewer tunnel system that is going through the main areas of Singapore. And I want to show this one, which is a concept, and it's not clear yet that it will, all the different components may go forward, but idea is that Singapore is, has enough rainfall on the land surface of Singapore to have enough water, fresh water for the population, but it doesn't have enough storage to allow that to happen, so they import a lot of water. So to make themselves more self-sufficient, they would store the water. They could make two-level caverns for storing the water and have a pumped hydro scheme between those. They would also be able to stop some of the flooding because, like other parts in the world, and I understand Helsinki a few weeks ago, they're getting heavier rains than they got before, and that would provide flood control. And then also they import all their aggregate. They don't have any open quarries anymore. They don't have any underground quarries. And designed in the right way, a long-term project like this could provide a lot of the aggregate supply within Singapore. So, but it's a challenge to get so many different components to all come together and be agreed on. A lot of transportation, like other parts of the world, they're looking to improve cycling and pedestrian, as well as put a lot of the traffic underground. This urban connectivity, here you can see Orchard Road, which is one of the famous shopping areas. It does have some pedestrian connections, but they've been made in a very haphazard fashion, and so they're rather confusing and not that convenient to use. And the planning department, the Urban Redevelopment Authority, is trying to figure out how to keep it with private, you know, because these are private properties connecting to private properties, but how to make the right incentives to get them to do a system which works for the public connections as a whole. Some of the interest from the futuristic point of view is that they are moving, or the dock and the container port from right by the downtown area all the way to the end of the island, the entire, one of the largest container ports in the world. And when they get it down there, they're also looking at building a tunnel system, a freight tunnel system, that would connect to various storage and interconnection distribution points, of which 2 of them may be in a series of rock caverns. And this they call the Estates Good Mover system. And there are studies of that are underway. And some of the new development areas or redevelopment areas, they're looking at these multi-level developments, pedestrian-only areas with the transportation down, 1 level, lots of new housing. So finding what's the right underground space to use is a challenge. Justifying cost benefit is another challenge. Coordination and getting the stakeholders to agree to do that. Integrating the requirements. There was a while where, people tend to write articles that were saying things like, Singapore is moving underground, and all of a sudden there's a public reaction, we don't want to live underground. And then the government has been, in the last 5 to 10 years, at great pains to say, we're not talking about having people live underground, but rather moving the things that don't need to be on the surface underground so that you'll have more space. And it's quite, it's very easy for the wrong message to go out. And they also are looking at building the right competency in people. They would rather that Singapore move from being an importer of experts into Singapore to actually developing the world leaders in these areas in Singapore and be able to export the technology. And when they do R&D, I was university R&D my whole life, and to me, project $400,000 was a big project, but when they do projects, a lot of their projects are $5 million over 5 years, and this fire and life safety in large-scale underground facilities was about 5 million Singapore dollars, about 4 million US, and also health and psychology impacts of underground space use, about the same amount. Doing very nice work, and particularly, I'd say because this has not been so much studied, that they've been doing some very nice work in that area that you can start to find in the literature. The blast vibration studies was not nearly as big as that. I forget how much that was. Work on the geologic database. You've got a very good system here in Helsinki, and so I don't think there's too much to say about that, except that it's well done, and there are legal provisions requiring the input of data. I believe even if you uncover an underground utility during the construction work, you're required to measure where it is and what it is and report that into the system. And then they have public information about what Singapore is using underground and what they're planning to put underground. And these are in public displays. They have very good exhibitions about their planning work. How am I doing for time? This is I like to use this one, but I don't want to take too much time. Let me just say it quickly. One of the things that a lot of people tend to feel that there's plenty of space underground, so if we mess up this bit, we'll just go and we'll use somewhere else underground. But if you take the volume of the Earth, of the whole Earth, and you compare that to a skyscraper that is 30 meters by 30 meters and 100 stories high, and then you look at the area that we have mined, or the deepest we mined is a few kilometers. So you take that few kilometers over under the land surface of the Earth, that in that 100-story building would be about the size of a 6 meter by 6 meter office by however high the office is. If you look under urban areas and take the first 30 meters underneath the urban areas of the world, what that volume is compared to the volume of the Earth is like a shoebox on one desk in one floor of that building. And that is the most useful underground space to support the infrastructure for more than half the world's population. So it's not an infinite resource. It's a very small resource, and we need to plan it and use it wisely. So to finish up, I think underground space use, there are other benefits, but it's mostly driven by land use considerations. There are major challenges with it. I've listed those there. 3D geologic data is essential, and we really, more countries need to follow the example of Helsinki and Singapore and Hong Kong and do the planning of the underground. And to figure out why isn't that automatically done? Why is there this sort of just only looking at planning at the surface and not just automatically including this important resource underneath with different space uses and groundwater and other things underneath. So with that, I will finish the talk, and maybe we can have happy to answer questions or to engage in discussion. Maybe some of you have some other ideas or some issues that I haven't touched on. So thank you very much.
Yeah, sorry, there is still time for questions. I think the coffee is already served, but it can wait. So please.
The first one is not a question, it's arguing you.
Okay, good.
Okay. You said that geothermal energy is renewable, especially if you load it during summertime. But we have made some calculations, modeling, and if you have a well deep 1,000 meter, it exists 50 years maximum, then it's zero at the temperature. And if you load it during summertime, you may have some 17 years more time, but it's only partly renewable. Yeah. Do you agree or disagree?
Yes, and when I said renewable, I was actually thinking more about there are some systems that are installed shallow, just below the surface. They go horizontally rather than down. And those systems, the sun regenerates the soil in the summertime, and if you extract the heat out, then it can be, close to being sustainable. But I'm glad you pointed that out, because I think that people tend to feel that that geothermal is, it's sort of like a long-term resource, but as you say, there's that if you're extracting it more than the center of the earth is replenishing or there's coming from the surface, then it is going to alter the temperature conditions in the ground, and in that sense, it may still be valuable to do, but it's not fully long-term sustainable.
Fine. Then a question about Singapore. We have both been there several times. So, and also Hong Kong.
Yeah.
So, even in the good areas with the excellent rock material, for example in Hong Kong, they always use this half-a-meter lining, even when it's not necessary to use. It's just, why is this the situation like that? You don't trust that the rock is self-supporting in these countries?
I think that it has to do a lot with the risk reward for the design process, that you know, from in the Scandinavian countries there's was a lot of development with relatively good rock, relatively unsupported, or you know, just what was needed. Caverns that have existed for for a long time, and so people could point, as you started to use public facilities, you could point to the experience with those facilities and say, we don't need that support. And I think that in Asia, there's not been the comfort level in the regulations or in the practices of the designers to essentially go without that support. Now, we did look at the three of us are on a sort of lessons learned study of different underground facilities, and one of the ones we visited already was a warehouse space, and it had unshotcreted rock, a few rock bolts, but not much in the way of rock bolts, as I remember. And they've been operating that for several decades. Now, they do scale the rock 2 or 3 times, 2 times a year, I think. But they do also have chunks of rock that fall out from time to time. And so far, no one's been in the wrong place at the wrong time. You know, I think that one of the engineers who was with us said we wouldn't do that anymore. We would at least put a layer of shotcrete over just to make sure that, you know, a loose piece of rock. This was a storage facility, so there were warehouse employees moving around inside the facility.
Thank you.
Thank you. Is there further any questions? I have one question back to the geothermal. There seems to be a conflict between the deep geothermal wells and underground structure in the density population area. So how have they solved in other countries? Do they allow people to drill deep boreholes in the city area?
I haven't tracked that, so I can't give you an authoritative answer, but I know that's considered a big problem in Germany, for instance, that they have, people have drilled forests, basically, of vertical borehole to provide geothermal. And that obviously then has a big impact on the routing or what you can do to put in later high-speed rail or metro or deep tunnels that go through that area. And so I think there is a conflict, and I think it's just that, that use, although it's been developing for 20 or 30 years, it's a fairly quick ramp up of that use, and I think that there has not been the reaction to that in the deciding what to do as planning terms to kind of regulate that, or to, maybe may have corridor reservations or other things, and I think that comes back to the fact that underground planning doesn't seem to be part of the overall planning process, in many cities. So, do you have some thoughts on that?
No, unfortunately not.
Yeah.
Okay, if there is no further questions, I suggest we give a big hand for Professor Ray Sterling here first.